Okay, I think we're live now. So, hi everyone. Thank you for joining this live stream. Hi, Dimitri. Thank you for making time for I think I've been looking forward to this event for a while, and I think I should introduce myself first. Hi, everyone. My name is Esimonde. I am the current DevRel for the Ethereum Nigeria community. And then today I wanted to do something like a little different. If you've been really active in the privacy space, you must have come across terms like, say, CE, which is Trusted Execution Environment. And then today with me, I have the CEO of QUEX, and I think I'm just going to give him the studio to, or give him the mantle to introduce himself and then tell us what it's all about. So, hi, Dimitri, over to you.
Yeah. Hi, everyone. Glad to be here. So thank you very much for making this real. I'm glad to be here for sure. And yeah, I'm Dmitry. I'm building in the space, like in crypto space since 2015, mostly as a researcher and developer. Now also as a founder and CEO. So I like technologies. I like the way how we can change the world with modern technologies. And TE is the one I'm focused right now, and yeah, I'm very excited in it and what's happening next. So we can start
Okay,
chatting about yeah.
okay. Okay, so I think the first thing everybody wants to know about is like, what is TE? Like, if you go up and look up the meaning of TE, first thing you begin with is trusted execution environments. It's a secure enclave in your computer where you can carry out processes in a way that even servers and administrator cannot penetrate. But like, how would you like explain it in your own terms? Like, why did you take so much interest in TE and like the vision you had for it?
Yeah, sure. So that's definitely good definition. So the TE briefly is the secure encrypted memory in your computer or even smartphone that allows to run programs within the isolated environment. It's fully encrypted. No one can access to it. Me as a host. Um, Even if you have like physical access to this computer, you cannot take a look what's happening inside, change the results of the TE, and that's the cool feature allowing like to make confidential computations on top of private data, and also verifiable computations. Yeah, so we can prove with TEs that this result is coming exactly from the enclave, and that's the most excited stuff for me at this stage. Um, and yeah, maybe before going next, I want to make it to simplify a bit. What is TEs? Yeah, first of all, likely all of you use it like every day. It might looks different. There are different versions of what we put in TEs, but in like your smartphone, you already have your TE space where your passwords are stored and so on. So for secure storage, that even if you have access to the laptop or smartphone, it's not possible to steal them. Yeah, that's one of applications just to store keys. That's how the space started to for storage keys, but now it's also applied for computations. For ones who are familiar with crypto space, it's quite similar to the approach of hardware wallets. Yeah, we all know likely Ledger or Trezor, but for computations, not T is not just for storage, but for computations. Yeah,
Okay, okay. Okay, so I think the theme for this whole live stream basically it's a AMA, and the theme for it is basically privacy in CE. Basically how it works, why it matters, and basically what the future holds. And it's developer focused. So I think we're going to be starting from a developer's perspective. And what we really want to know is how does CE-based privacy actually work and why anyone should trust it, what you can build on it now, and basically like where it's headed. So I think I'm just going
yeah.
to now like what was your goal for QX? Like, what did you have in mind? What does it do? How do the developer community benefit from it?
Yeah, you asked a lot of questions. So regarding the T, why we are using it, the technology evolves significantly, and I see that right now we are at the space at the point of time where it evolved significantly, and we finally use it for to solve real problems. Yeah, there might be different approaches for sure. Yeah, we'll likely talk more about FHE, ZK, and that approach, who sometimes serve similar stuff, so suitable to serve similar tasks. T evolved significantly. What we have right now is like virtual machine-based approach, so we can encrypt the whole virtual machine within the if your CPU supports T space, and start perform computations, private computations. It was first designed, yeah, for confidential computing to process private personal data from customers, and it's not for Web3 space originally. It's not designed for Web3 space specifically. It's not like crypto space. We do a lot of computations on top of sensitive data. We don't want data leaks. They happens a lot of time, and T helps you to secure very sensitive data, even if to ensure that like hosts cannot steal your sensitive data, or even your developers or hackers can do it if they get some kind of access. Yeah, that's important stuff in terms of privacy approach. Yeah, because we want to remain private, at least in a lot of cases. It's super important.
Okay.
Yeah, I can go forward
So,
with that, or
I think that's like a lot of information, because when anybody hears, the first thing that comes to their mind is privacy. And then I think I also really focus this event on QX. Like, you're the founder. So, like, can you tell us about like privacy in CEE enabled oracles? Like, how does QX utilize it?
yeah, that's the piece I told a little bit in the beginning. We use TE for a little bit different purpose. Yeah, so originally it was designed for confidential computing, for privacy. We use it for verifiable computation, so we can run any kind of program within the TE. So how it technically works? Yeah, we put a virtual machine within the encrypted environment. We can extract sound proofs that the exact virtual machine execution environment and program is running within this encrypted environment. And for the following inputs, this program provides the following outputs. Yeah, that's some sort of proofs. It's different than ZK proofs and other approaches. Nowadays, it's called confidential computing proofs, but it's very lightweight. It's super efficient approach, and it allows you to prove programs that are not covered by other techniques. Yeah, one of them is making requests all over the web. Yeah, you likely all know, as we are in Web3 space, smart contracts can't make HTTP requests all over the web. That's the nature of smart contracts. They had to be deterministic. All the validators should have the same result for computations. Otherwise, they won't find a consensus in terms of the current state. And if you're making network requests, they might provide different results for the same request, yeah, different time for different requests. And like T is the only approach, as far as I know right now, that is suitable for this kind of tasks. Yeah, it's the only approach that can do this. Are actually arbitrary programs, yeah, and not limited with deterministic programs and small ones. Thus, we efficiently solve the problem of data oracles. The problem exists for a long time, as we cannot get external data from our smart contracts. We need to rely on some parties called oracles that bring this data on. But unfortunately, this is still a big point of vulnerability in a lot of smart contracts. 400 million US dollars are stolen every year with attacks to oracles, price oracle manipulations. In most cases, it's because people use oracles incorrectly. If you'll go to recent hacks list within the last month, you'll see two big attacks related to price oracle manipulations with more than $10 million lost. So the problem is still big, and we can simply solve it using the TEs. That's why I'm excited with it.
Okay. I think that makes sense because if you've been following the Oracle reports, or should I say the ARC reports has been going on, one of the major source of attack has always been Oracle price manipulation and everything. So, and I think that's why I'm really excited about QUEX because um, including privacy at a very serious point of error. Like smart contract cannot get data from the real world, and then we rely on oracles to deliver those data to the smart contracts. So one of the best ways to actually manipulate a smart contract would be to manipulate the oracle. So I think I love the whole architecture and how QUEX is approaching privacy. So I think my next question now would be like, how does attestation work? Like, what's private and public, and how does attestation work inside the enclave? How does that whole
Yeah.
process go?
Yeah, sure. Yeah, as we already mentioned, like TE is hardware-based approach, so we need specially designed chips, CPUs with private keys built in during the manufacture phase. In this sense, it's pretty close to hardware wallets, where you create some kind of private keys that never leaves this chip. And using this chip, we can create derivatives from this chip. We can create encrypted pieces of memory, allowing you to put your program within this encrypted environment. Until we have these guarantees from the manufacturer, we have to rely here on the manufacturer guarantees that the CPU is built correctly. But that's the only assumption we have right now. Unfortunately, in previous times, you had to have more assumptions that we may talk about it a little bit later. But right now, it's possible to use T in such a manner that the only trust you need is that the chip was manufactured correctly. If it was manufactured correctly, then the rest of the process is pretty straightforward. So we have an encrypted enclave. We have a private key that encrypts all this enclave. We now corresponding public key. We can push it. It is signed with the certificates chain, so we can ensure that this enclave is encrypted using private key that was created during the manufacture phase. Derivatives from it, definitely not exactly that key. But that's this is called attestation report. Attestation report allows you to extract a chain of signatures to the concrete enclave. The chain of signatures is going back to root vendor public key. In our case, we rely on Intel chips, so we're going to Intel root certificate, ensuring that they sign that they manufactured this chip. This chip is manufactured correctly, and and now we have something running within this enclave. That's the tricky part, because we don't have the whole program. We only have a hash of the whole environment with the build state in attestation. So we have a hash of the program execution environment, virtual machine, and the process, how it was allocated to the memory. Within attestation report. Definitely, we need one more step to ensure that to compare our program if we want to ensure that we run a concrete program with this hash. This piece of technology was missing for years in the industry. We released it a bit more than 1 month ago on verified.quex.tech. If you go there, you'll be able to reproduce. You give a snapshot of virtual machine, and we'll reproduce the measurements of TD. That will allows you to ensure, okay, we got attestation report states that TD measurement is 1, 2, 3, 4, 5, and then you recalculate it locally in your browser without any TD. That this 1, 2, 3, 4, 5 hash exactly is exactly the hash for the virtual machine you're running. Yeah, that's quite tricky part. It's pretty heavyweight in terms to verify this certificate chain within smart contracts, but it's possible to do it. Yeah, it's possible to verify this attestation report within the smart contracts. Fortunately, we have to do it only once. Yeah, so that's heavy and more or less complicated program, but hopefully we have to do it only once, because within the same attestation report, we put a freshly generated public key, while private key is stored within the virtual machine. And after that, all the requests and response we just sign with the freshly generated key, and it's very lightweight. It's very lightweight signature. You have to just compare that the results assigned with the predefined with this public with the private key corresponding to public key we see in attestation report, and this means that the result is coming from the enclave. Yeah, otherwise it's not possible. By design is that we only have this private key within the enclave, and if we have a result coming from this enclave, this means that that is here. Yeah, so that's what technically we do in terms of verifications and proofs. All the proofs are verified within smart contracts. It's pretty important step here, so you don't rely on any trust or any like off-chain stuff. So within smart contracts, we verify both certificate chain and signatures of the recent results. Thus, if you're building smart contracts that rely on QUEX, it's technically impossible that it will take results that are not coming from enclave. Yeah, because we performed all the verification. The result is definitely coming from our encrypted environment, and we, by design, by manufacturer guarantees, we are not capable to see what we are processing here or to manipulate the result to change something.
Okay.
That's a piece of
Okay. I think so basically I think I got one question, and the person was like, what are like some design trade-offs one should consider when choosing T-based privacy over methods like ZK Snark and everything? Like, are there some design trade-off? Is it slower? Is it faster?
It's much faster. So TEs are, as I know them, the most efficient approach right now. The overhead compared to like centralized execution, untrusted execution of the same kind of program is just like 20-30%. As it depends on the program, but average number like this. If you go to the ZK space, it will be like 1,000 times slower than what we have in TEs. It will be, the proof size will be much bigger. Also depends on the program size and everything else, but it will be much slower, much less efficient. And that's actually one of the points that we use for QUEX as oracles, because like if we need data to be delivered fast, we cannot wait for a long time proof generation. There are cases when it's not that crucial that the data is delivered fast, but in some cases, actually in a lot of them, it's very important that we have a very fresh data on chain. And these cases, you cannot rely on a ZK approach. We made measurement compared to QUEX with ZK-TLS approach. So ZK-TLS is privacy preserving oracles like ZK Pass or Reclaim. And for then proof generation is stated to be 2 seconds, but actually it's much slower, because besides of ZK proof generation, they have additional steps. For us, it's like 4 milliseconds, so it's very big difference. And for us, time to generate proof is negligible with compared to just latency of our requests. So we don't care too much on it, and doesn't provide additional costs and make a difference. Yeah, we have some kind of delay, but it's just the network latency among our servers that generate these proofs and the blockchain nodes that will take it and put on chain. For ZK approach, it might be a big difference, and it might consume a lot of time. So T is the most efficient and practical approach right now. That's for sure, and I believe even people from ZK space or FHE space will tell you the same. There might be some benefits of using other approach, but in terms of efficiently, T is definitely the best.
Okay. I think T is actually. I think I read the benchmark results from Fala Network, where they posted like some inefficiencies while using a T-based approach. But I think that's a conversation for another day. And now I think I would love to talk about like some use cases. Since the Oracle takes privacy first, what are some practical use cases a developer should look into when integrating QUEX? Like,
Yeah, definitely. So for sure, we design QUEX to be the most flexible stuff right now. Yeah, so when you need to get any data from any data source, you can use QUEX. You can use QUEX to bring public data, like prices from crypto exchanges. It is possible to do it. There are other oracles who solve the same issue, and maybe it's not our unique feature. When we become unique and more interesting is when you're going to have non-standard data. It might be credentials protected data, so you have API key. And again, as far as we rely on very standard cryptography with no public key of the enclave, of corresponding enclave. So you can encrypt your private data, like your API key, for example, and T will be able to use, like our enclave will be able to use your API key, and you have the same security guarantees that your API key never leaves the enclave. So it will be used just to make one request. You put it in an encrypted form. It is decrypted within the enclave and used to pass private information within the request. That's the cool feature we have. We call it a private patch, so we can patch your request with some kind of private information you don't want to reveal on public, but it's still verifiable that exactly exactly this decrypted patch was used within our request. So it's your request, you made request to maybe even your personal bank account to get information that you own some kind of money or you are verified. It might be a KYC provider. We are coming to use cases space. I believe that the space is changing significantly right now, changed already a lot. We're more coming to integrate Web3 space with the real world. We have real world assets. We have legal frameworks coming. And that's why we need a lot of data with no public access. We need it on chain, or we need to use computation results on top of this data on chain. Yeah. So if you're going to create tokenized stocks and you want to trade them, you cannot just legally, you cannot just allow anyone to trade stocks. They have to pass some kind of verifications that it's legal person able to do this. And we can bring this some kind of check mark that yes, this address belongs to he passed me his money not stolen from anyone, so we have proof of source, but without revealing personal information like even my name, surname, passport number, and amount of money I have in my bank. Yeah, so we can bring proof that yeah, this is the person. He exists in. He is a client of this bank. He have balance more than 100K, so he is accredited investor. Approve him to use these operations, and that's it. But actually, we reveal nothing more than you need.
Okay, so I think TLS and zero knowledge TLS could actually work hand in hand with T for that kind of application.
Definitely, yes. The funny stuff regarding like zk-TLS is that it always consists of two parts. So they have a first part to get data from the original data source and prove that the response is coming exactly from the exact data source. Yeah, so like this data is coming from, okay, I started with the example of the bank coming from the bank. Yeah, so they have, this is the first part. And the second part is to extract only the necessary piece of data from the whole response. Thus, they're not revealing too much on chain. Yeah, they reveal only a check mark that, yes, it's like a person, and that's it. So for the second part, to extract only the necessary piece of data, zk-TLS approaches use zero knowledge proofs, and that's how they call them ZK. For the first part, to prove that the response is coming from another from the concrete data source, it's not possible to use ZK. Yeah, you have to use different approach. That if you'll go deeper to ZK Pass or Reclaim or any other ZK TLS projects, they will tell you that for the first part we use something else. It might be proxy, more quite centralized proxy. It might be multi-party computations. It might be TEE. So they usually write that it might be TEE, but actually, if you use TEE for the first part, you don't need ZK the second one. You're going to use TEE for both to prove that the response is coming from a concrete data source, and the same technology to extract only a necessary piece of data. That's what we are doing. Yeah, that's what we are doing. We use T here and here to prove that the data is coming from a concrete source, and for post-processing to process the response before putting it on chain. Funny stuff that even in such a case, it's still called zk-TLS in the community. So even our approach would be called zk-TLS, but actually we don't use zk, yeah, because we already have more standard actually cryptography, simpler cryptography on like elliptic curves. We don't need this advanced but popular by some reason ZK stuff.
Okay. I think that explains it. So I think now I want to talk about what is possible to be able to pair. Like what integrations are available for developers, the SDKs, maybe like an API, or how they could get started using QX Oracle.
Yeah, definitely. So we are live on 10 networks like right now. If you are interested to use us on other networks, feel free to DM us. We are very responsible. We will respond and try to support you. Yeah, has already dropped correct link here. So go to docs.quex.tech and see documentation. There is a getting started guide there that is very simple way how to write a first contract. It already uses SDK our interfaces that simplifies you some kind of measurements and development. So it will be pretty fast to develop your first contract that rely on QUEX as data oracle. If you'll need more complicated examples, step by step, definitely you should go and use QUEX for more interesting cases. Yeah. So just go to the documentation, try our getting started guide. I hope it will be fast and funny. You'll get some fun and you'll understand how it works. If you keep in mind something more specific and you don't know how exactly to build it, just contact with our team and we'll support you.
Yeah. You can join the QX Discord and ask. I think you have a very responsive team. Initially when I got started, I got lost, and all I had to do was bring on Discord, and I got support immediately. And one thing I love about
Yeah.
QX is that it is EVM compatible. You don't have to like learn a new programming language to get started. Just the way you interact with any other Oracle, it's the same way you interact. You don't have to change anything, and it's just pretty much the same thing. And I'm just going to, this live stream was scheduled for 45 minutes, and we have like 11 minutes remaining. So I'm just going to go ahead and look for more questions from the audience and see if we have any. Okay. I think I got one question. Like the person is asking, can I build custom logic inside the CEE, or do I only interact with previous endpoints from QX?
At this point, but very good question. At this point, we have our like HTTP Oracle example that is making the request and response. In a little bit later stage, I hope in 1-2 months we'll allow to build any kind of logic within the T. So it might be completely different. Whatever you want, actually, it might be neural network AI agent that lives within this enclave. It might be a game with verifiable results. So we're going to release it pretty soon, the whole stack, how to orchestrate with enclaves, trusted domains, so you'll be able to put your virtual machine, or likely Docker container within it, to write your logic on programming language you like, and you'll get verifiable results from the T. This is not that far, so we are close to the stage that we are ready to deliver it. So far, it's not public, but if you have concrete example and use case in mind, please reach me. I'm not very active in Discord, being honest. My teammates definitely, if you want to reach me, go to Telegram or Twitter, and yeah, I'll respond for sure. So if we are definitely looking for interesting use cases. We see that we have a very powerful tool right now in our hands, and good applications are always welcome, especially if it's like the applications that is not possible to do before us. Yeah, the only way to implement this kind of applications with TE with QUEX technology. That is super cool. So we'll be happy to support and to do something together, maybe even together. Yeah.
Okay. Thank you very much for that. And then I have one very interesting question. I think this person is an open source enthusiast. So the question is, are you planning to open source any part of the C code base or proof mechanism?
Definitely, we are going to open source all of it at some point. We are open sourcing it step by step. For like verification part, I told like verify.quex.tech. We already open sourced it, and there is an npm message package that allows you to reproduce DD measurements in JavaScript. So you can do it even in browser. We are passing our security audits right now, and after that, we'll open source our smart contracts. And regarding the DE stack, so it will be open step by step, not everything right now, but definitely it should be open source. I agree with you. So we're just not releasing it too early to be able to make it works and secure.
Okay, thank you. And thank you for answering that question. So, like, I think I'm getting checking for more questions. So, thank you everyone for being part of this live stream up until this point. And if you have any questions, you can go ahead and drop it on the live stream. And if I already said if you wanted to be a part of this studio, you can always just send me a DM and you're part of this studio. And give me a moment to check. Okay. So I think so. What are like the roadmaps you have for QX Oracle? Like, what are the roadmap? What are things we should be expecting, and where are we currently?
Yeah, definitely. So we're polishing our TE stack. That hopefully, as I just told, within like 1-2 months, it would be possible to write your own custom oracles. So everyone will be able to just build own oracle, run it within the trusted domain, rely on TDX and TD approach, and get like verifiable results. So, we have a lot of thoughts how to make it more developer friendly. You definitely need more tools, more like SDK documentation. So that's still a bit missing point from our side, because we evolve very fast. We deliver our technology very fast. Sometimes we are not that fast in describing what we've done. That's one of the points of going to AMA sessions, because we already have much more than we had 1 month ago, and we just need to describe it, and we want you to know what's happening right now. One more important change that is expected this year is to finally make QUEX fully permissionless network. So if you have a special, like correctly set up hardware like TV, you'll be able to join our network and start producing proofs to the client. So we have smart contracts that consumes verifiable results. Yeah, and we have TEs that produce these proofs and verifiable results. Yeah. So far, we're working in permissioned mode. Hope we'll soon announce very, very exciting partnership that we won't be the only ones already who produce these TE proofs. Another pretty big project in the space is joining. We are joining to make pilot integration to show that actually the TE community is pretty united, and you can rely on other TE providers. They have correctly set up hardware. You can use it within the QUEX network to deliver verifiable results. So that's the plan. I think till the end of the year, yeah, in terms of development, two main achievements. We want to have allow anyone to run programs of their choice within the DE and allows anyone to actually run these programs. Yeah, and makes it as a decentralized network as it should be. Thus, if me and all the QUEX team will disappear tomorrow, it will continue to do its job with no way to stop it. With no trust required to ourselves. That's our point, and definitely, yeah, finding new interesting like business goals to find new clients, integrate new chains, find new interesting use cases. There's still a bit of, again, the chicken problem here that we now have a lot of new possibilities, even with just private data, private oracles. It's new tools. It was missing in the space for years, and no one knows how to use it. There are no applications yet for it because there are no tools that are capable to do this stuff. And we are very excited to see what will happen next. Who will bring the next interesting applications, the next unique application, DeFi, RWA, prediction market, doesn't matter. For us, it's freedom. It's freedom for building something cool. We want to provide this freedom for everyone using QUEX as an infrastructure. So just just be limited, like imagination, and create the next generation apps in the space.
Okay. Okay. I think that's a pretty. We'll be looking forward to every development along the road. And I think it's at this point, the one last question I have here, person is asking like, what are the supported network on QX? So I'm just going to share my screen. You can find out more info on docs.qx.tech, but I'm just going to share my screen to show you what particular networks are currently supported. And if you give it, oh yeah, just let me know when you can see my screen.
I don't see a screen yet. I can tell about the networks. So we support EVM networks, Ethereum Arbitrum, Binance Smart Chain, Avalanche,
Hello.
Caldera, Xella, XDC, Red Belly Network. I might forgot about. We recently integrated Waterfall. Actually, I think it's not public yet, but we published the announcement. Yeah, you know, yeah, Bera, Arbitrum, Avalanche, Bera, BNB, Sila,
Yes.
Ethereum.
So these
Yeah.
are basically mainnets, and then there's also the testnet network. So if you're building on Arbitrum, Sepolia, Avalanche, Chain, okay. So these are basically testnets. And if you need any more information, you can find everything on the documentation page. So I think one more thing I wanted to say is the QX documentation is pretty simple to use, and it's very straightforward. No too many technical talks, and just straight to the point, how to get started and how to get building and everything. So
Yeah,
I think that's
so
it. So,
yeah.
so if that's a question you ask, you can always go to documentation and find more info there. And I think that's all the question from my end. Yes, I think that's all the question from my end. So thank you once again, Dimitri. Thank you for making out time for this. And like one thing I always love to do is if you have like any, should I say, last words for the developer, and basically to get to know more about you. And when I read your bio, you said you have a PhD in you're a PhD physicist. Like how does someone go from a PhD in physics and goes straight to the whole Web3 ecosystem? So if you could like think about your journey, we would love to know more about you.
Yeah, okay, sure. So yeah, I'm originally physicist by design, and I was always doing like computer simulations and physics, but some are close to computing, writing code, and starting to work as software developer. So I was very early into getting involved in the crypto space. I was one of the first employees at IOHK, that is currently known as Cardano Developers Input Output. At that time, it was pretty small R&D lab. Well, my goal was actually to be somewhere in between of research and development. And that, yeah, I was very excited with the possibility to change the world with technologies. Yeah, we can eliminate risk, we can make it more safe place, provide economic freedom for people in the space. So I like a lot this technical focus on the crypto space at all, and that it's at the cutting edge, I think, of making the world better with the technologies. So yeah, that's how step by step I was deeper and deeper involved in the whole space. I made a bunch of my own research in cryptography, in economy, in computation theory. Published it on peer-reviewed conferences, presented it. Back in 2017, we decided to make a spin-off from IHK and launched Ergo platform. It was my first project as a founder already. It's layer one protocol, still alive. Pretty cool, actually, at least in terms of technologies. Maybe not that big as it could be, but provided a lot of exciting verifications of research ideas. So we were the first who implemented a lot of different ideas, research ideas in practice, and evaluated how it actually works. And some of these innovations were adapted later on in other blockchains. Some of them not, but it's fine. And yeah, like step by step, again, I change my focus a bit, go to ecosystem stuff, developing ecosystem. I started to look more how people building read startups from good technologies that I was involved in startup space as investor advisor for pretty long time, exploring how people doing startups, how they're raising money, how what is important here, how to do this stuff, how to do the business, not just technologies that will be used by others. And yeah, that's how I came to QUEX almost 2 years ago already, a bit less. So the idea to do something as a founder, I think, appeared 2 years ago already. And at that stage, it was just an idea that I want to focus on something single, not to spread my attention to a bunch of different projects, startups. I help a lot, but that's likely not my my mindset. I want to focus on a single stuff. That's why we've started QUEX with my co-founders. Pretty super happy to have cool people on board, co-founders, our team members, and when you're working on a cutting edge on technology, you have to attract very interesting people to you, and likely they will come. You'll see a lot of people that likes to be innovators, like to change the world, and that's very cool community around us. That's what I like here. Long story short, that's my life within the last 10 years, at least in terms of professional background. I live in Cyprus right now. If anyone is around, drop me a message. We'd be happy to meet in person. And yeah, likely see you on any conferences related to our space.
Okay. So thank you very much for actually making time for this. And this was a very, very interesting chat. And I think with that, we've come to the end. We've been able to answer all the questions. And then This video will always be live on my page. So if you missed the session or you're just joining in, you can always go back and then get a recap. And thank you once again, Dimitri. Thank you to the entire team at QX Oracle. And okay, till next time.
Yeah, thank you. Thank you very much, Hassan. It was a pleasure to be here with you. Thanks everyone for
Thank
watching.
you.
Bye
Bye. Bye.
bye.